quick question for you, Mr. Grace. I'd really like somebody to go further into the concept of reverse gravity and dark energy, because it seems that as more is explained about the creation of the universe, there are more and more X factors emerging, and this is one of the most recent ones, and certainly seems to be one of the most mysterious.
Hi, Alice. So you're asking what is dark energy and reverse, or I suppose anti-gravity, really consist of? And that concept came out of the observation, as you know, that the universe, which is expanding, is not expanding at a steady rate, but rather the rate of expansion is increasing. The universe has accelerated expansion. And that's hard to explain because some people, in fact, expected to have found that the universe would deaccelerate, since matter tends to cause the universe's acceleration to slow down. Gravity is always attractive, so if there's matter or energy, it will pull in and reverse the expansion. The accelerated expansion, therefore, could be due to anti-gravity. Well, that's not the case. Anti-gravity doesn't exist, we believe. What we do believe is, if you want, an X factor that explains the accelerated expansion, but it's a very old X factor. It's one that dates back to the beginning of Einstein's theory of gravity, of general relativity, in which he understood that there could be a form of energy that pervades the universe. We call it sometimes vacuum energy. It's just energy of empty space that would act in a way like anti-gravity. Not so much because of the energy, but because of the pressure of this stuff. The vacuum could behave like a gas or a fluid with both energy and pressure. Now, normal matter, a normal fluid, has positive energy and positive pressure, and that causes things to get attracted and contract. But stuff that appears naturally in Einstein's theory has negative pressure, positive energy, and negative pressure. And it is that negative pressure that actually causes the universe to have accelerated expansion. So that's the simple explanation of this accelerated expansion of the universe. It's natural because it's the one form of a kind of fluid filling the vacuum that wouldn't be an ether, that wouldn't pick out a preferred observer. It's the one form of energy and pressure of a fluid, if you want, or of a substance that would look the same to all observers. Ordinary fluids, made of ordinary matter, look different to different observers, moving with different velocities. They have different energy content. Much like an automobile has much more energy when it's moving fast than it does when it's at rest. But this kind of fluid, because it has negative pressure in just the right amount, equal to its energy, in magnitude and opposite in sign, is just arranged so that all observers, no matter how fast they're moving, would see the same amount of energy and negative pressure, and therefore couldn't tell which was the preferred observer, the preferred frame of reference. So this is the one kind of energy and momentum allowed in the vacuum pervading the universe that doesn't pick out a preferred observer. So it's allowed by the theory. We should expect it. Therefore, from that point of view, there's nothing strange about this observation of the accelerated expansion of the universe. And in fact, we can test whether the energy and pressure are exactly related as Einstein's theory would predict, so that there was no preferred observer, and it works out very well. So there, all is well. The only problem we have as theoretical physicists is to understand the magnitude of this energy. Where does it come from? We sort of know that quantum fluctuations in quantum mechanics, the fluctuations of all fields and particles, will give rise to an energy that pervades the vacuum, but we have no way of calculating how much energy will be produced, and all of our attempts so far have gotten the wrong answer. So whereas we don't understand the magnitude of this energy by any means, we, or at least I, am very comfortable with the phenomena itself and its explanation.